kq2 by x2 square. Now the ratio of this electric field is asking, he is asking that the electric field at O is same for both the charges. Means these two are equal. Actually it should be mentioned magnitude. The directions are different. So if electric field magnitudes are equal, then I can get kq1 by x1 square equals to kq2 by x2 square, which gives you q1 by q2 is equals to x1 square by x2 square. So that means simply we got get the value of ratio of q1 by q2 as x1 square by x2 square. So this is the solution of this particular question. Based on Coulombs law, very simple question. This is also a time-saving question. You can save some time from this question and utilize in some application of continuity questions. Now we go to the next question. Now this question is based on thermodynamics, I think. A balloon of radius 3 cm having an ideal gas of pressure this much bar is kept at a certain temperature. What will be the process? What will be the pressure of the balloon at the same temperature having the same amount of gas in the radius of 12 cm? So this is a simple question of thermodynamics where you have to understand that the radius of the balloon will give you the volume of gas inside it. So initially, what about the temperature? Initially, what about the temperature of the gas? Based on the temperature, same temperature, we have just increased the volume, and he is asking what should be the change in pressure. That is the question he is asking. So obviously, like P1 V1 is equals to N into R into T1. Now N is the number of moles, as he has already told that same amount of gas, so obviously number of moles remain same. Now we get P2 V2 is equals to Nr into again the same temperature. All of you understand why the same temperature? Because the temperature remaining unchanged. So obviously this is a process in which you can write P1 V1 equals to P2 V2, which gives you the final pressure as P2 equals to P1 V1 divided by V2. Now V1 by V2 depends on the radius of the balloon, so which you can write as P1 into V1 by V2 can also be written as R1 cube by R2 cube. So just you have to see what is the relation between R1 and R2. So all of you can understand R1 by R2 is 1 by 4. So you get P1 divided by 64 because R1 by R2 will become 1 by 4 and 4 cube is 64. So we get P1 by 64, which can be written as 48 into 10 to the power minus 3 divided by 64 bar. 1 bar is 1 atmospheric pressure, which is 10 to the power 5 Newton per meter square. Again, it's a very simple question based on thermodynamical process, and in which we don't have to worry about how the temperature is changing because temperature remains constant. So this is the solution of this question. Now we go to the next question. The next question is 4-point masses of mass m are kept at the corners of a square. It is rotating with an angular velocity omega as shown. Find the angular momentum of the system. These are all memorized questions, so we don't have a detailed idea about how it is rotating, whether any mass is existing over there or not. If I assume that there is no mass of this connecting rods, let's say this mass, let's say we have to understand